The species you belong to has been here before, not this exact version of it, but something like it, a primate lineage, diverging from its relatives, developing something new, becoming something that had not existed before. It has happened at least a dozen times in the last 6 million years. Different hominin species rising, spreading, existing alongside each other, and then disappearing, until only one remained. The question is whether that process is over, whether the thing that produced humans once could produce something again, whether the one remaining hominin species on Earth might, given enough time and pressure, split, change, become something that is not quite us. The honest answer is more complicated than most people expect, and it requires understanding what evolution actually is, what it requires, and what has changed about the human situation that makes the question genuinely difficult to answer. Evolution by natural selection requires three things: variation, differences between individuals in a population; heritability, the ability of those differences to be passed to offspring; and differential reproduction, some variants leaving more offspring than others because of those differences. When these three conditions exist, populations change over time. Traits that improve reproductive success become more common. Traits that reduce it become less common. Given enough time, populations can diverge so far from their starting point that what results is something categorically different from what began. This process produced every species that has ever existed, including the one reading this. The question of whether it will produce a new human species depends on whether those three conditions still apply to us. Variation, yes. Humans vary enormously in almost every measurable characteristic: height, disease resistance, metabolism, cognitive patterns, sensory acuity. The raw material for natural selection is abundant. Heritability, yes, partially. Many human traits have significant heritable components. Not all variation is genetic, and not all genetic variation is expressed in ways that affect survival or reproduction. But the heritability condition is broadly met. Differential reproduction. This is where it gets complicated. For most of evolutionary history, differential reproduction was driven by the environment. The traits that helped an organism find food, avoid predators, resist disease, and attract mates in a specific environment were the traits that got passed on. The environment was the filter. Different environments filtered for different traits, which is why populations that were geographically separated for long enough eventually became different enough to be considered different species. The modern human situation has largely disrupted this filter. Modern medicine, agriculture, and technology have dramatically reduced the degree to which environmental conditions differentially select for biological traits. A genetic variant that would have been lethal in a pre-modern environment can now be carried and transmitted across many generations. A trait that would have provided significant survival advantage in a hunter-gatherer context may have essentially no differential effect on survival in a modern urban environment. The filter has not disappeared entirely, but it has been substantially weakened in ways that have no precedent in the history of life on Earth. For a new human species to evolve in the way previous species evolved, two things would need to happen. First, populations would need to be reproductively isolated from each other for long enough that genetic differences could accumulate without being diluted by interbreeding. Second, those isolated populations would need to face different selective pressures that drove them in different directions. The first condition has become dramatically harder to meet. Modern humans are more genetically connected than at any previous point in history. Global travel, migration, and interbreeding between populations that were previously geographically separated have been steadily reducing, not increasing, the genetic differentiation between human populations. The direction of movement is toward greater genetic homogeneity, not toward the divergence that precedes speciation. The reproductive isolation that allowed earlier hominin species to diverge is not operating in the modern world in the way it once did. But there is a scenario that changes this calculation, and it is one that human technology is actively making more plausible, not less. Space. If human populations were to establish themselves on other worlds, on Mars, on moons of the outer solar system, in orbital habitats, those populations would face a combination of factors that could, over sufficient time, produce genuine speciation. They would be reproductively isolated by distances that make regular interbreeding with Earth populations practically impossible. They would face radically different environments, different gravity, different radiation levels, different atmospheric compositions, different diets, different psychological pressures from enclosed artificial environments. And if those populations were small enough at founding, the founder effect, The disproportionate genetic influence of a small founding population could accelerate the divergence dramatically. A population of humans established on Mars, isolated from Earth for tens of thousands of years under meaningfully different selective pressures, would not necessarily remain human in any biological sense that a taxonomist would recognize. The gravity of Mars is approximately 38% of Earth's. Long-term exposure to lower gravity produces measurable changes in bone density, muscle mass, cardiovascular function, and fluid distribution. Natural selection in a low-gravity environment over thousands of generations might favor different body proportions, different bone structures, different cardiovascular arrangements from those that evolved under Earth's gravity. Add the radiation environment, the dietary constraints, the psychological demands of enclosed living, and the selective pressures diverge significantly from those that produced us. There is also the possibility of directed evolution, the deliberate modification of the human genome through technology. CRISPR and related gene editing tools have already demonstrated the ability to make targeted changes to human DNA. As these technologies develop, the question of whether humans will choose to direct their own evolution, selecting for disease resistance, longevity, cognitive enhancement, or environmental adaptation, becomes less hypothetical and more pressing. If different human populations make different choices about genetic modification, if, for example, a population in a high-radiation environment edits its genome for radiation resistance, while a population in a cold climate edits for cold tolerance, then the genetic divergence between populations could be accelerated enormously beyond what natural selection alone would produce. The result, over enough generations of sufficiently different modifications, could be populations so genetically distinct that interbreeding becomes limited or impossible, which is, biologically speaking, the definition of separate species. This is not science fiction. The technological trajectory is real. The question is the social and ethical one, whether human societies will permit or encourage the genetic divergence of populations in ways that would eventually produce biological speciation. The history of human societies suggests that this will be deeply contested and that different communities in different circumstances will make different choices. The timeline is also important. Speciation in the hominin lineage has historically taken hundreds of thousands to millions of years. The conditions that would accelerate this, small isolated populations under strong selective pressure, are not currently present on Earth. They might be present in space colonies, but the distances and timescales involved extend far beyond any planning horizon that makes most humans comfortable thinking about. What is perhaps most interesting about this question is what it reveals about the nature of our current moment. For the first time in the history of life on Earth, a species is capable of understanding its own evolutionary situation. It can look backward and see what produced it. It can look forward and reason about what might come next. It can make deliberate choices that affect its own biological future in ways that no previous organism ever could. Whether those choices lead toward a future with one human species or many is not determined by biology alone. It is determined by the decisions that humans make, individually, collectively, politically, ethically, about what kind of future they want to inhabit. The process that produced us is not finished. It is waiting to see what we do next.